going live, and I am live. Excellent. How many people are there? Got 2 people so far. Good. Again, pay attention to those due dates. That Edulastic thing is due Friday. I already have like a large handful of people already turn it in. The project for you guys is due on Monday. Make sure you are contacting me. If you have any questions, we'll be able to go over them. Don't wait for the last minute. Please don't wait for the last minute. In the past, it's been interesting. Like, let's say I have a project due on a Monday like you guys. In the past, like, I would randomly get like an email at 11 p.m. on that Sunday night with a student being like, I don't know what I'm doing. I'm like, it's 11 p.m. the day before the project's due, and now you're emailing me. Oh my goodness. Make sure you're contacting me with plenty of time. But as I said, the goal for today is to take a side step. Hello in the chat. He's saying hi to me. I'm going to say hi back verbally, and then I'm going to say hi like this. Hi. There we go. Good. And gentlemen, I want to show you Desmos. Let's take a look at Desmos. Some of you are somewhat familiar with Desmos, but I want to remind you of a couple things with Desmos. Check this thing out. I want you to visually see what I'm about to show you. This is really insanely good. Y equals ax squared plus bx plus c. Add all. There we go. Look what I got here. Now, you may not have seen anything like this before, but in Desmos, I just typed in a generic quadratic equation. Ax squared plus bx plus c. And in Desmos, they allow you to do this special thing called add a slider, which is really nice. And right now, the values of a, b, and c are all set to +1, which results in the following, if I can get my actual marker here, here it is, which results in the following quadratic. It's just the quadratic y equals 1x squared plus 1x plus 1. That's what that quadratic is. What's really nice about this website is that it allows me to do stuff like this. Check this out. I could take that value of c, and I could do this. I can do that. I can even hit play right here. Watch this. And it just does that. What the quadratic's doing right now, go back to geometry in your minds. Go back to geometry. I know it's terrible, but you gotta. In geometry, you learned about transformations. Transformations. What type of transformation is being displayed in front of you right now? What type of transformation is that? Ooh. I know geometry is like something you'd wish you'd rather forget. It starts with the T. Close. Very close. It's a translation. Also known as a slide. Now, beyond that, I could stop that right there and put that back at 1 real quick. There we go. I could also do the same thing with A. Check this out. I could do You know what it's called when I flip that quadratic upside down? What's it called when I flip the quadratic upside down? It's another transformation. Isn't that weird? I'll hit the play button. Look at this. Yeah. Yeah, when it flips completely upside down, it's reflected across an axis, then yes, it's called a reflection. This thing is kind of showing a reflection. It's not a precise reflection. In fact, if I wanted it to be a precise reflection, I would leave that there. There we go. I'd leave it at 1 there. Go to 1. There we go. And I'd actually put in a y equals negative x squared minus x minus 1. Now it's an actual true reflection. But that's not the purpose of today. Check this out. I could even do this. Watch this. Oh, watch what it does with the b value. Look at the b value. This is my favorite thing. Look at the b value. It's so funny. I don't even know. You do all 3. Desmos is such a fun, silly little thing. Put that over there. Put that over there. I want them to be off kilter. No, keep playing. Hold on. You play there, and you play there. There we go. Anyway, whatever. Go back here. Go back here. Go back here. Go back to 1. Go back to 1. Go back to 1. There we go. I want to focus on this quadratic. This quadratic was the first one I showed you, the y equals x squared plus x plus 1. And my job is to solve that quadratic. I have to solve it. I have to figure out what the solutions are. I have to figure out what the roots are. I have to figure out what the zeros are. I purposely left off the last term. What would the solution to this quadratic be? If I had to find a root, a solution, a zero, I named them 4 things actually. These were in your notes from way back when, but I called them roots, I called them solutions, I called them zeros. If I'm trying to find the solution to this quadratic, what am I looking for? What am I trying to give? It's where it crosses somewhere. What am I looking? Where crosses what? If I'm looking for the solution to a quadratic, I'm looking for it to cross what particular location? This goes back to factoring. For example, if I were to put in this quadratic right there, this is a different quadratic now. This is a different quadratic. This is the quadratic 1x squared plus 1x minus 6. What would the solutions to this quadratic be? If you had to give me a number. Guess a number. Any number. I hear crickets. 2. 2 would definitely be a solution. Why? But you guessed correctly. You did guess correctly. Why is positive 2 a solution to this graph? By the way, there's a second solution. You want to take a guess? Say again? Negative 3. Negative 3 is the other solution. Why?
Because that's the point at the
Correct. If I am looking for the x-intercepts, that is the solution graphically. That is the graphical solution to this thing. In fact, if I were to take this and do like a 0 equals x squared plus x minus 6, and I were to use the Tucker method of factoring to get these 2 factors, and then I would end up with, get rid of that. I would set these equal to 0, and I would get negative 3 and positive 2, which are the 2 numbers you gave me. You told me positive 2, you told me negative 3. They're my solutions. Graphically, they're represented by the x-intercepts. So I go back to the other example. Where I change this to a positive 1. What's my solution? What's my solution? Ooh. What's my x-intercept? You're shaking your head. You don't have one. I want to correct one tiny thing about what you just said. He said there's no solution. I want to correct one tiny thing. There's no real solutions. There's no real solutions. Now, I'm not going to talk about the opposite of real solutions today. I'm going to talk about the opposite of real solutions next week. But there are what we call 2 complex solutions, or you probably better know them as 2 imaginary solutions. But we'll get there. We'll get there. I don't like the word imaginary, though, because imaginary implies that it doesn't exist. Let me show you another one. Check this out. I love this thing. What if it were a 2, a negative 1, and a negative 6? Nope, not a negative. Yeah, negative 6. There we go. Perfect. Now, clearly, you can identify what the 2 x-intercepts are. You can visually identify them. There, I clicked it right there. Let me show you one additional calculation. Look at this one additional calculation that I'm about to type in. There we go. the heck is that? I don't know. This may or may not look familiar to you. This calculation of something called b squared minus 4ac. This may ring a bell in some of your minds, but regardless of what b squared minus 4ac is, regardless of that, the b, the a, and the c are coming directly from these three numbers. It's coming directly from these three numbers. Look what b squared minus 4ac equals for this problem. Do you know what's so special about that number? Perfect square. I wonder if that has anything to do with it. I don't know. Maybe. Let's see what happens. Let me go back to the other problem that we did. We did a problem where it was like, hold on, where it was 1x squared plus 1x minus 6. This was the other problem. That's the one where you guessed 2, and that's the one where he said negative 3. What's so special about 25? Oh my gosh. That can't be a coincidence. Let me do another one. I got it. Check this out. Let me give you a weird one. Check this out. 4, 0, negative 9. Now this equation, this quadratic equation is strange because I made the b value 0. This is the equation y equals 4x squared minus 9. The b value in the middle is gone. It's technically b equals 0. B equals 0. So it'd really be like 0 squared minus 4 times negative 9. Oh my gosh. That can't be a coincidence. Now, actually, in reality, here's the unbelievable thing that I'm not going to write this into our notes, but if this number from this calculation is a perfect square, it actually means that this is factorable. It actually means that this is factorable, which it is. This problem would factor into 2x minus 3, 2x plus 3, which would give you answers of positive 1.5 and negative 1.5, which are right there, where they cross the x-axis. But there are problems that are not factorable. For example, if I did a 1, and yeah, let's just do that one right there. Boom. Negative 9. This is not factorable. I want to make a very clear distinction here. This is y equals x squared plus x minus 9. This is not factorable. It's not factorable, but I ask you the following question, which, by the way, look, not a perfect square. But I ask you the following question. Does this graph have two real solutions? It does. Why? Yeah, clearly it crosses the x-axis twice. It has two real solutions. Its solutions are right there and right there. But how do we find them if we can't factor? How does one find them if we can't factor? Let me go back to the very, very first equation that I put up there. This one. Boom. This one you told me had no real solutions. No real solutions. What do you notice about this number? What's so interesting about this number? It's negative. Watch this. I'm going to show you something. I'm going to use that slide thingy. Check this slide thingy out. Oh my gosh. Check out this slide thingy. Let's go back to C. Nope. Go back to 1. There we go. Yep. There we go. Watch this. Watch this. Now, I caution you when I move this thing around. Yes. Watch the graph. Watch the graph. But also look at that number when I move this thing. Look at that number when I move this thing. Look at this. Oh, come on. Slide it down. Look, two real solutions. Two real solutions. Slide it back up. No real solutions. No real solutions. It's interesting how this thing kind of plays out. Let me do this actually. Check this out. Boom. Pause. Two real solutions. Look at that number that I have the arrows around. Now watch this. It's going to go back up. No real solutions. Look at the value of the number with the arrows. Put this back to here. Play. It's positive, 2 real solutions. It's negative, no real solutions. There's a reason why that happens. Look how close that thing is. Hey, check this out. Hold on. I'll do one more. Check this out. I'll do one more before we get to our notes. Look at that one. How many solutions does this thing have? It looks like it just hits it, right? And look at the value of that. Oh crap. Oh crap. You remember this stuff?
Yeah, I remember doing this.
Algebra 1? Yeah.
I did.
That's okay.
I just remember that if it touches, there's one solution. If it crosses, there's 2. If it doesn't touch, then there's none.
I want to specify no real solutions. Yeah. Because next week we're going to get into non-real solutions. It's going to be great. Ladies and gentlemen, if you do not already have them out, I'm going to need those notebooks out and open. Do. Here we go. Put it over there. Let's call this solve quadratics by quad formula. Today is the 7th. You want to know something crazy? Today's progress reports. That means you're halfway through the marking period, which means you're 12.5% done with the school year. This is messed up. Okay. First, we have a quad equation. This is what I typed into Desmos. This is what I typed into Desmos to start this thing. This is your generic quadratic equation. ax squared plus bx plus c. This is how you recognize what the quadratic looks like. It has to have an x squared. Let me show you something on Desmos really quick. Check this out. Let's say that, and watch this. It goes down. Look at that. What's that red line? Is that a quadratic anymore? No. The a value can't be 0. Silly. Back to this. The a value can't be 0, just as a side note. But then I introduced a special calculation known as the discriminant. The discriminant is a hugely important number. The value of the discriminant will tell you a lot of stuff in regards to that quadratic. A lot of stuff. In fact, if your discriminant is greater than 0, as we talked about, then we will have 2 real solutions. If your discriminant, which is just a word that's just fun to say, then you would have 1 real solution. It's very strange. In fact, the example, I have one more thing to write there, but the example that I gave you for the 1 real solution thing was actually this equation right here. It was y equals x squared plus 6x plus 9, where if you factor it, can you think of 2 numbers that multiply to 9 and add up to 6? 3 and 3, the same number twice, right? Which means that this would factor into x plus 3, which gives you an answer of -3 and -3, it's the same number twice. One real solution. That was the one real solution example. It's really weird. Back to this. And if your discriminant is less than 0, meaning that it is a negative number, then for now, you will have no real solution. Or no real solutions, I should say. Because technically, you could have 2 different types of solutions, but we will get into those details in a little bit. For now, let me kind of melt your brain and give you the quad formula. Now, the quad formula is by far one of the most important formulas that you will see in all of Algebra 2. Let me give it to you very deliberately like this. The quad formula is x equals a big old fraction. For some of you, you may recognize this formula. For some of you, this is like severe PTSD. We'll get there. It starts out with a -b. Then it has a little plus or minus action going on there. Now, again, yes, when I say plus or minus, it's a plus and a minus on top of each other. That means that you're going to have 2 solutions, one using the plus and one using the minus. Well, which one? You use both, but you got to separate them. We'll get there. Then there's a big old square root. Then there's a big old square root. Inside of that square root is something that should look very familiar. B squared minus 4AC, your discriminant. And the entire thing is over 2A. This formula. Now, I don't give too many stars in my notes. By the time December rolls around, you could probably count the number of stars that I put into your notes on one hand. Rest assured that if I give you a star in your note, or in your notes, I should say, it is going to be important. If you cannot solve by factoring, the quad formula will always work. If you cannot solve by factoring, the quad formula will always work. Now, keep in mind the project that you guys have due for me on Monday. Factoring should work in every single one of those problems. If they don't work, then you need to go identify what mistake you had. But if you can't solve a problem by factoring, the quad formula will always work. You'll basically get to a point where it's like, well, I can't solve it by factoring. Quad formula it is. I need you to think back. Think back to elementary school. My son right now is learning addition in the sense of like addition that results in 2-digit numbers, like 9 plus 7 and 5 plus 8 and some junk like that. But he's in first grade. I don't know what year you guys first learned like multiplication, division, all that fun stuff. But I ask you the following question. In all your years of mathematics, calculations, there were 2 things that they told you can't do that. Because if you did, your calculator would say, error. What are one of those 2 things? What are 2 things in mathematics that you're never allowed to do with calculations? Oh, divide by 0. I don't know if you were making a hand gesture or not. Say it anyway. Oh, good call. That would be a more advanced thing. That would be more like a middle school thing. That's actually called the commutative property, and it only applies to addition and multiplication, but it doesn't apply to subtraction and division. But you can't divide by 0. That's one thing. You can't divide by 0. You divide by 0, the world blows up. You can't do it. This problem, or this equation, I should say, this formula, the only way you divide by 0 is if this a value is 0. But as we talked about, if this a value is 0, then you don't have a quadratic. If this a value is 0, then you don't have a quadratic. Let me move this over a little bit. Did the screen freeze on me? It froze like my heart. Hold on. Click. Click. There we go. I wanted to move this over because some people are trying to see it in the chat, and it got that glare on it once again. You can't divide by 0. The world would blow up. What else can't you do? There's one other thing. There's one other thing in the annals of mathematical calculations that you are not allowed to do. What's the square root of 49? Sure. Why? Sure. Now, mind you, the numbers that I'm choosing are numbers that you've already seen today. What's the square root of 25? 5. We got that. Cool. What's the square root of 144? 12. Because 12 times 12? Yeah. What's the square root of negative 4? What's the square root of negative 4? You can't say 2 because 2 times 2 is positive. And you can't say negative 2 because a negative times a negative is a positive. Cube root. You can take an odd root of a negative number, but you can't take an even root of a negative number. You can't take the square root of a negative number. Man, I wonder why I would be bringing up the idea of taking the square root of a negative number. I have no idea why that would come into play. Do you guys remember the name of this thing? What's this thing called? The discriminant. And like, what happens if that discriminant just so happens to be a negative number? Because you can't take the square root of a negative number. Because if you tried to take the square root of a negative number, then you would have no real solutions. That's the way this thing plays out. Now, again, no real solutions for now. Next week, I am going to show you how to actually get solutions from that. Zoom in, 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 zoom in. Check this out. If you tried, we were trying to figure out how to get Jose Altuve to a 400 average in mathematics of sports. That's what that was. Anyway, if you tried to take the square root of a negative number, watch what your calculator does. Watch what your calculator does. Chapow. Oh, hold on. Get rid of that plus sign. Chapow. Non-real answer. Until I could do something like that. You ever seen that before? I'm so excited. Anyway, we'll get there. We'll get there. That's not for today. Today, the focus is this. Quad formula. Let's see. Somebody give me a number. Any number. Sure. Let's go with 8. So I am going to write down a problem, an example that I would like you guys to do. And I'm going to have you solve that by the quad formula. Let's do this one together. So the example using the number 8 is going to be x squared minus 8x. Let me make sure this works properly. I got to make sure those numbers work properly. There we go. Plus 12 equals 0. There we go. That'll work. That'll play. That'll do exactly what I want it to do. Now, believe it or not, this one's actually factorable. But I want you to solve by quad formula. Here's what I'm going to have you walk it through. First of all, What do you notice about this equation and what it is equal to? What's it equal to? It has to. It has to be equal to 0. If it is not equal to 0, then you are in for some trouble. You need this equation to be equal to 0. If it's not, you're going to have to move some things around to get it equal to 0. Then I'm going to identify the values of A, B, and C. In this case, the value of A, well, it's an ax squared, so that's a 1. You gave me 8, but I made it a negative, so I made it a negative 8. And in order to make this problem work, I had to make it a 12 for my C value. Cool. Let's calculate the discriminant. The discriminant, b squared minus 4ac, I'm going to calculate this separately. It's supposed to be b squared. Now, I may have said this before, but I will say this again. Parentheses will save your life. What is negative 8 squared supposed to be? Yes, but watch what happens here. Parentheses will save your life. I thought you told me it's supposed to be 64. It's supposed to be 64. You need parentheses, ladies and gentlemen. You need parentheses around that negative 8. Please make sure you know the difference in the calculator, especially when you use it. Just be careful. Parentheses will save your life. If you do this calculation, let me do it like this here real quick. Negative 8 squared minus 4 times 1 times 12. Technically, you don't even need the 1 there. Oh, look at that. It equals 16, which just so happens to be a perfect square. Remind me one more time. Where does the discriminant go in the quadratic formula? Where does it go? Yeah, it's a very important thing to remember that. A lot of people end up messing up several things. Let me show you what people mess up. Let me show you what people mess up first of all. First of all, I've seen people do this. I've seen people do this. I'm like, no, that negative doesn't belong there, it belongs there. I've seen people do this, where they're like, okay, negative 8 plus or minus the square root of 16 over 2. And then this is like negative 8 plus or minus the square root of 4 over 2. And then no, when you take that square root, the square root goes away. I've also seen people do this, where they're like, okay, negative 4 plus or minus the square root of 8. No, that is not how you simplify this thing down. There are 100 different ways that you can mess up. 100 different ways you can mess up this problem. I need you to avoid those mistakes. Yes?
Are you allowed to, for the are you allowed to replace the 16, or can you replace the b squared minus 4ac, can you replace that with the 16?
Yeah, because we calculated it separately.
So you can.
Absolutely. This is just a helpful technique. You don't have to do it this way. In fact, if you wanted to, you could do this. You could be like, okay, negative b plus or minus the square root of b squared minus 4 times 1 times c, the whole thing over 2 times a, and then you can try to calculate that out. But what ends up happening more often than not is students tend to try to throw that entire thing to the calculator, and they royally screw up. And then they panic, or they write down whatever the calculator said, and they just trust it. I'm like, nope. If it's helpful, calculate this separately. And if you calculate it separately, what you just asked me is exactly what I'm going to do next. Watch this. Here we go. The quadratic formula is x equals, now, watch what I write, but listen to what I say. Negative b I said the words negative b. The b value was negative 8. So if I say negative b, I'm saying the negative of negative 8. It's very strange. Plus or minus the square root of the discriminant, which I already know is 16, because I did that separately. The whole thing over 2 times a. In this case, my a value is 1. Your job is to break this thing down piece by piece. There are 3 pieces. There's the negative 8, which now becomes a positive 8. There's the square root of 16, which becomes a 4. And there's the bottom of the fraction, which becomes a 2. Now, I'm not done yet. I am not done yet. But I just want to emphasize how easy this problem can be if you break it down piece by piece. Simplify the negative b. Simplify the square root of the discriminant. Simplify the denominator of the fraction. At this point, you have to evaluate the problem once with a plus sign and once with a negative sign. You have to evaluate it as 8 plus 4. Then you have to evaluate it as 8 minus 4. If I evaluated it with 8 plus 4, I would get 12 over 2, which is equal to 6. And if I evaluated it as 8 minus 4, I would get 4 over 2, which results in a positive 2. These are indeed the answers to the problem. Now, I'm going to leave this up here for a moment, but check this out. X squared minus 8x plus 12 equals 0. Okay, a times c is 12. Okay, give me 2 numbers that multiply to 12, but add up to negative 8. Careful. They got to be negative because I got to add up to the negative. So it's like negative 6 and negative 2, which keep in mind, this is not my answer. This is not my answer. These are my magic numbers. I don't really have to do a t-chart, but I'm just going to do this anyway for the fun of it. X minus 6, x minus 2 equals 0, which results in answers of positive 6 and positive 2, which are the same answers we got over there. It does the same thing. But I bring you back to the star statement that I made, the star statement. If factoring is not going to work, if you can't solve by factoring, you have to do the quad formula. The quad formula will always work, regardless of whether it gives you nice answers or not. All right, let's try this one. Oh, that's a fun one. Look at the worksheet that I gave you. Look at the worksheet that I gave you. We're going to do this one a little together. And I want you to look at number 6. I believe it's number 6. Is number 6 the one that starts off 15x squared? Cool! Let's do that one together. First page. There's the first page. I believe it's 15x squared plus 22x equals negative 8. Cool. This is example number 6. 15x squared plus 22x equals negative 8. Cool. We got to solve by quad formula. What do I do?
You have to set it to 0.
Can't do anything until I get it equal to 0. Cool. Now what? Remember, you're not factoring. You're not going through the Tucker method. You don't have to do GCF. You don't have to do A times C. What should I calculate first by itself? Starts with the D, ends with an discriminant. You got it. I love the discriminant. The discriminant is b squared minus 4ac. Let's just calculate that separately. So we get a 22 squared minus 4 times 15 times 8. That looks terrible. That looks terrible. Oh my gosh. Let's just see what this thing says. That looks horrendous. 22 squared minus 4 times 15 times 8. Holy crap. Just gave me a 4. Make sure you type that thing in correctly. Type it in correctly. But yeah, your discriminant was a 4. That's kind of nice. All right. And then what?
You plug that into the quadratic.
Let's do it. X equals negative b, which in this case is 22, or negative 22. Plus or minus the square root of 4. The whole thing divided by 2 times a, which in this case is 2 times 15. Break it down piece by piece. The negative of the 22, oh crap, that's just like negative 22. Plus or minus the square root of 4, which is just 2. The whole thing over 2 times 15, which is just 30. Nice. Piece by piece. Now I have to evaluate the plus or minus. All right. Negative 22 plus 2 is negative 20 over 30. Just simplify in a moment. And negative 22 minus 2 is negative 24 over 30. Oh, crap. So that'll give me the fraction negative 2/3, and that'll give me the fraction negative 4 over 5. Huh. That's strange. I mean, that's cool. That's nice. Let me see what the Tucker method would look like. Let me just see what the Tucker method would look like. I'm just really interested in this. If I did a times c, I'd get 15 times 8, which if you did that in your head, that would give you 120. Can you give me two numbers that multiply to 120 and add up to 22? It's a lot simpler than you think. Two numbers that multiply to 120 and add up to 22. Yeah, it's a lot. Sometimes it's super easy. Sometimes it is super easy. Sometimes it's not so easy. 10 and 12. T-chart. 10 and 12. 15x, 15x. Simplify, 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 simplify. I'd get 3x plus 2 and a 5x plus 4 equals 0, which should look very familiar to the answers that we got. Subtract 2, divide by 3, subtract 4, divide by 5. Clearly the same answers. Clearly it was factorable. But they're not always factorable. They are not always factorable. Give me a number. Give me any number. I can do anything with numbers. 15? Sure, let's do 15. Let's do a 15 here. You know, it's funny. People always stick to single-digit numbers. I don't know why. But why not do a 15? Let's do a 15. Let's try it with example 2x squared plus 3x plus 15 equals 0. There we go. There's my 15. Let's do it. B squared minus 4ac should give me 3 squared minus 4 times 2 times 15. That really, if I go to my calculator, 4, 15. Wait a minute. You sure you want to do 15? Yeah.
My God, my angel number is.
I got negative 111. Oh, man. This is really going to screw things up.
Okay, we can work through it.
But what happens when you take the square root of a negative?
Oh wow, it's not. There's no solution right now.
No.
There's no solution.
Real solution.
Yeah, what I was saying.
Here's the thing. This is the exact reason why I had you calculating the discriminant separately. Because if your discriminant happens to be a negative number, you are done with the problem. For now. For now. There's no real solution at all. Can't do it. Won't work. We'll go back to Desmos. If I did a 2, 3, and 15, you wouldn't be able to see what was going on here. But look at that. There's the quadratic. No real solution. You can even see it right down here. Look at the mouse. Right here. You're right there. Negative 111. It won't work. All right. Next problem. I don't know. You know what? I have an idea. I'm going to keep the same problem, except I'm going to change one thing. I'm going to keep the exact same problem. Watch this. This is going to be insane. I'm going to keep the same exact problem, except I'm going to change one thing. Look what I changed. I got a good feeling about this. Let's see what happens. Going to calculate that discriminant separately. B squared minus 4AC gets me a 3 squared minus 4 times 2 times negative 15 this time. Let's see what the heck happens here. Zooming in, zooming in, zooming in. 3 squared minus 4 times 2. I get rid of that times there. I get rid of yeah. Times 2 times negative 15. Oh, nice. 129. It's a positive number. Huh. I wonder. I think you may have stumbled upon something here. Hold on. Is 129 prime? No. Ooh. Interesting. Look at that. You could break it down 3 and 43. Nice. You could break down 3 and 43. Okay. Did you guys ever do Pythagorean theorem in geometry? With the triangles, right angle triangles? Did you ever have to simplify down radicals and square roots? Right? Where, for example, if you ended up with an answer that was like the square root of 50, you couldn't leave it like that. What did you have to do? Do you remember? It's like the square root of 25 and the square root of 2. And then it'd be like 5 root 2 and some junk like that. You would technically have to do the same thing here. You would technically have to try to do the same thing here. Now, try to do the same thing here. I'm emphasizing the word try, because sometimes it won't work. Sometimes it won't happen. Let's see what happens. If I did this problem, I would end up with negative b plus or minus the square root of 129, the whole thing, over 2 times a, which in this case would be 4. Now, you can try to break down that 129. Again, the best you can do with the square root of 129, you can only break it up to like the square root of 3 times 43. But tell me, is 3 or 43, are any of those perfect squares? Can't do it. You can't break down 43 any farther. The square root of 129, you would have to leave it as the square root of 129. So what do? How do you simplify this crap down? How in the world am I supposed to simplify down negative 3 plus or minus the square root of 129, the whole thing over 4? You don't. You just circle it. There's another way you could write the answer. You could also write it like this. You could also go -3/4 plus or minus root 129/4. You could also write it like that if you wanted to. Perfectly acceptable. Perfectly acceptable. Let me show you something here. Check this out. Let's change this to a -15. Holy crap. Look at that. 2 answers. 2 terrible looking answers. Oh, I got something better for you. I got something better for you. Check this out. Look at this. Look at this. Look at this. Look at this. I got something much, much, much better for you. Watch this. Look at this. So I got this 2 things right here, and they cross there and there. Now watch this. This is the craziest thing in the world. Watch what I'm about to type in here. Now, I'm about to hit enter in a moment. But look what I've just typed in. I've just typed in the answer. I've typed in the answer with a giant set of parentheses around the top of the fraction. It's parentheses -3 plus, I'll do the minus in a minute, plus the square root of 129. Close the parentheses. Now, this is the weird syntax error on the calculator where you got to close it on the square root and then close it on the top of the fraction, but then the whole thing over 4. What do you think is going to happen when I hit enter for that x value? Where is the cursor going to blink? Look at that y value. That's perfect. That is perfect. That is exact. That's your x-intercept. That's your solution to the graph. Let me type in the other one. -3 minus the square root of 129 divided by 4. This is the other answer. There's one answer using the plus sign, and there's one answer using the minus sign. Boom. Look at that thing blinking right there in all of its glory. It's wonderful. People think the calculator can do it all. The calculator can do it all. You just have to know how to make the calculator do it all. You guys have no idea how much this calculator is even capable of. You guys don't even know that there's like this inherent speaker system inside the calculator built in the 90s. It's really like rough and rudimentary and scratchy, but it's there. Guys just don't know how to access it. It's crazy. Anyway. You guys ever hear it speak? Really? Remind me next week. Oh, I'm sorry. Maybe if we have time. We'll see. I don't know. You can think what you want. Have I proven to you to be anything other than a genius? That's true. That's very true. That's very, very true. Now, well, actually, I might have time. Maybe we'll see what happens. Now, let me just show you this one thing on Desmos because this is absolutely phenomenal. Check this out. Desmos, again, I don't know how much time you guys have actually spent using Desmos. Any at all? On Desmos? Cool. Doing like stuff like this or stuff like crazy experiments? Was it stuff where you had like drop balls and the balls moved?
Yeah, it was stuff like that. It was I was in that one.
Mm-hmm. Yeah, that class didn't last long. It was supposed to be, their thought was that they were going to take all these kids who didn't score well on the like state testing or whatever, or they just missed passing by like a point or something, and they would put them in these like extra math classes, and they thought that they would be able to like push them over the passing line. State tests are ridiculous. But anyway.
It didn't work. And like it was really weird the way that they had it set up because they said, like you said, they had to score that well.
Yeah.
But I scored pretty high on the test and they still put me in class. So like,
Did you miss about like a point or something?
no, I actually like I was like well over like what I needed.
Oh, that's weird.
So like it was the same thing with another conductor.
The organization and where they placed kids and how they placed kids was so misorganized, to say the least. But anyway, check this out. I could type this whole thing in. It's really crazy. Or I can go like negative b divided by, do a little 2a action here, do a little plus sign, throw a little square root in there, do a little b squared minus 4ac. Boom. And it does that calculation. I'm going to copy that, and I'm going to paste it here, but I'm going to change that plus sign to a minus sign. You can program all this stuff in one shot. It's absolutely phenomenal. I can go back and change this to -1, -6. There we go. Where it actually does give you nice looking answers. Desmos can do it all. Have you ever seen this? Check this out. This is really cool. Get rid of that. Let's see. Marble slide. Marble slide parabola. There we go. Where you can go into. No. Go back. There it is. Cool. Where you could like drop marbles and like have it hit the stars. It's really cool. You know, or it's like something like this, like, oh no, I couldn't get the marble with the parabola. So you could change like one thing about it and then relaunch it and then you get it. Success. It's super cool. I love this thing. Love this thing so much. Or like, hold on, I can move this over. Plus, no. Make it minus again. And move it over to that. Move it over to that. That could do it. Let's change that to a 3. Nope, to a 2. No, that might not. That'll definitely not work. Woo! Nope, totally didn't work. Whatever, don't care. Oh gosh. So we do have time if you want me to show you that calculator thing. If you have a Chromebook, break it out because it could still work on your Chromebook on the TI-84s. See, what happens is the original TI 8384 calculators were built back in the 1990s. And they originally had the intention for kind of like a basic kind of like speaker system. But they didn't really have the money to finish the programming. So they kind of left everything as is inside the casing. But the code is still technically there. Now, what you have on your computers is something called an emulator. Do you guys know what an emulator is? An emulator is something that is supposed to replicate or recreate some kind of system. Like typically, if you're familiar with online video gaming, you know what an emulator is. Here, I might have one here. There it is. Like I have an emulator for example, for like Super Mario Bros, for example, you know, where like it has everything that Super Mario Brothers has. Anything that was programmed into the cartridge for Super Mario Brothers is here. It's emulating what the cartridge would look like, and I can play the game. That's what an emulator is. So on your graphing calculators that you have open, if you look at the bottom of the calculator, see where the number 0 is? On the emulator? What's written above the number 0 in like little letters? The word catalog. If you hit second 0, it'll bring you to an alphabetical listing of every single function that is programmed into that calculator, right? Now you have to scroll down to the T's. There is another way to get down there, but this might be a little bit fast. If you press and hold, does it automatically keep scrolling? Sweet. Okay, good. That's because I'm not as familiar with these emulators, but these emulators can do everything that these other calculators can do. It's really insane. Let me know when you get down to like the T's. I speed run video games. That's why I got all this stuff here. It's pretty awesome. My buddy built me a computer with a terabyte worth of old retro video games. It's insane. You're at the T's? Okay, cool. You have to look for one specific function in order to make it active because usually it's kind of set to off when you start. You have to look for the function that says gullible. There you go. And my day is complete. So I'm gonna sign off in the chat. You guys have about 5 minutes, but all right. But we're good. We do have about 5 minutes, so we are going to end a little early. But I would remind you again, remind you. If you have any questions about the Edge Elastic assignment that is due Friday, or questions in regards to the project that is due Monday, please make sure that you are jumping on that. Today is just Wednesday, so we do have plenty of time left in this week, and of course during the weekend. But as I mentioned to you guys earlier, and I mentioned to you guys on the chat, I will not be available during the weekend. I will be sleeping in a hammock somewhere in the woods in New Jersey. I don't know where, but we'll find out. Bye-bye. Chapow.